I recorded a whole lecture yesterday, but the frame rate was too low for some reason, and I hope I have fixed it. If I haven't fixed it, then it's going to be another irritating day for me. Um, Please pay attention to the new chapters outline, and this is a two-dimensional index. It is not A B C D E F G. It is K, K, G, G, Ch, 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 T, 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 P, P, B, B, T, Th, 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 Y, R, L, L, L. So if you can't read Devanagari, you will have to Google it. But it doesn't really matter. What matters is that in Latin script, B comes after A for some reason, but this is more structured. So I prefer it this way. And then there is nothing for K and G and Gh, while there is P, P, B, B is completely filled up. But maybe there will be topics here in the missing spaces which would be related to the horizontal line. We will start with K, celestial sphere and original astronomical wonder, and the other, the brightness and magnitude and apparent and absolute brightness. Those videos they will go in P, properties of stars. And we are starting with celestial sphere. I had uploaded a video about just a primer video about what really the concept of celestial sphere is and what we should be thinking about when we think about classic astronomy, because astronomy, I mean, the simple fact that Earth goes around the sun has been a matter of huge debate, and most people, I think all of the people except astronomers, have not really come to understand what it really means. Now, obviously, most people will tell you that they know that the sun doesn't go around the Earth. It goes so they know that this motion of the sun, as in this whatever you're seeing right now, this they think, oh yeah, obviously this is, we know that the sun doesn't go around the earth, it's the earth that is rotating in this scenario, and that is why it looks like sun is rising and setting while it is just we are who are rotating. And that's fair, but we have known this for thousands of years. That was never the problem. We knew earth was round and earth was rotating. When we say that we declared that, I mean, Copernicus discovery, or the great heliocentric model or the sun centered model, that is not talking about this motion at all. That is talking about the yearly motion. So this, in a year, sun goes around the earth, and that is something that most people do not know about. What does that even mean? In a year sun goes around the earth? But we kind of know about it, because they talk about Makar Sankranti when sun enters the constellation of Capricorn, except when you actually go and look at the sky on Makar Sankranti, it is not in Capricorn. So something is wrong there, but you still hear this, that sun enters this constellation and that constellation. And what does that mean? What does it mean, sun enters a constellation? Well, it is not really difficult to think about what it is. That is actually going to be another video about zodiac. There is a list of topics here: zodiac, nakshatra, and seasons, and um, astronomy, that is now only seen in astrology. But yeah, I won't spend a lot of time on it. Last recording, I spent a lot of time on it. Okay, I hope that the FPS is good, because the last time I recorded it, it was like not moving. It was very annoying and would have been a pain to see it. Okay, now I want to talk about coordinate systems in this video. And I told you that I told you nothing. I told you, but you didn't hear because I didn't upload because the recording is bad. Okay, anyway. So looking at this sky, we need to come up with a way to name all of these stars. Name as in not, Capella, Aldebaran, and Betelgeuse. Name them, give them an ID that you can identify, but not the stars themselves. You need to give a ID to every position in space. So when we do that so you need to basically able to put a grid here somehow that will give give a coordinates to each of these things. So in normal three-dimensional space, we use x, y, and z coordinates, and we locate a particle with these three coordinates. Here now, when you look at this sky, which is okay, it is night sky, and it is just, well, it's not the entire sky because Earth is blocking half of it. Doesn't matter. You can see that you don't know the distances to these things. Now, it would be that moon we know, and if there's no planet, but if there were planet, then we would know. But what about all the other stars? It is that okay, we can determine distances, so most of these stars we know their distances from us, but it is not a given. There might be farther stars that we don't know the distances to them yet or accurately. So we can't have the radius component. We can only have the directional component. So all we need is a direction to point to a star. Direction from where? So the first very simple system that you can think of is just, think about, we need references, right? The number of coordinates that we need the same number of references, because something has to be 0 for other things to be 1, 2, 3, 4. And that first coordinate system that you can think of very easy is that you think of the top zenith. That is a direction you can always tell. Zenith is on top of your head, and the other would be the north, because, well, you can tell where the north is, because if you play this, okay, you can see that everything is going around the north star. That is, well, I don't really like that explanation, but I mean, yes, obviously, because Earth is rotating, and it's rotating in a very strange way. The Earth, it goes down below like this towards the north, and it rotates. And it is actually very interesting. If you actually are able to visualize this rotation, it is mind blowing. Okay, so you can tell where the north is, and you can tell where the top of your head is, and that's just the two things you need to locate a particle, a star in sky. So how would you do it? Let us say that you want to know what is it, how do you point to, how do you parameterize, no, coordinatize Vega? What are the coordinates of Vega is what you're asking. And in this simple system, we can think of how much is it from the horizon, this angle, and how much towards the east it is from north. So actually not this angle, but all the way around this, almost 360 in this case. And that would be the position of Vega. And okay, it is difficult to see what I mean, so I will just switch on the alt-as coordinate system in Stellarium. So Vega, now you can probably guess where it is. Even you don't even need to read these numbers. Is 1, 2, 3, 4, 5, something like 55 degrees. And no, wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there are totally 9 segments. 1, 2, 3, 4, 5, 6, 7, 8, 9. So each one is 10. So you have 1, 2, 3, 4, 5, 6. Oh, sorry. It's like 65 degrees altitude. This is the altitude. It's raining like mad suddenly. It was bright just 10 minutes ago. And you have, okay, so you have 1, 2, and 3. And well, there are not 10 segments this way. There are, I mean, this has to be 0 to 360. So I don't know what each of these segments is, but we can simply go and see it. The horizontal ones are 5. Okay, no, but that's when you zoom. No, it is still 5. Okay, no, now it is 10. Is it? It is 10 now. Okay, and where is Vega? Okay, Vega is here. So this is 30 to the west, so that is 330 degrees to the east. So the coordinates for this star would be something like 65 altitude and 330 azimuth. And if you go and see altitude azimuth 330 and 65, exactly what I told you. It starts with azimuth. Azimuth is the angle that you start measuring from the north, and then you go around and you come to wherever your star is. Like for example, for Deneb, can you guess the altitude and azimuth for Deneb after I have guessed it for Vega? Um, Pause the video here and try to guess it what it would be. You can assume that it is at this cardinal point or vertex of the grid, and you can tell me what this grid point would be in the altitude and azimuth system. Can you tell me why this is the bad system? No one uses it, not even amateur astronomers. We just, if unless you have an altitude azimuth telescope, there is no point using this system because, well, first of all, everyone's head is pointing in different directions. So this is not a universal standard point, even for people on Earth. Horizon is not standard. North may be a bit standard, but still, this is the problem because see, if I oh no, the coordinates are changing every single second. So how is this useful at all? Well, it is not, because just even to derive the trajectory of Vega in altitude azimuth, it's a pain. So we don't use this system. This is just to yeah, it looks nice though, how we are looking at the sky through the dome. So this is another thing to remember, that celestial sphere and the coordinate systems, they are earthbound. They're nothing out there. It is very earthly systems. And okay, so I'll show you the other system which is more important, but before that I want to show you uh, uh, I will have to pause the recording just a second. Okay, it is recording again. This is the latitude and longitude system on Earth, which is very convenient. We all use it, and it can be arbitrarily precise. Like I can tell you this point here, but you know, you can't tell. You can tell latitude and longitude for a building, but you can't tell which floor is the person that you are looking for sitting on. So there is no 3D component. It only maps like 2D Earth, but Earth is not really 2D, but it works mostly. And that is what the latitude longitude system is. I hope that you're all familiar with it. This is the Greenwich meridian, which is considered zero, as one of these longitude lines had to be zero, right? Like origin has to be somewhere, and in a circular space it is more interesting than linear space, and they put it here for some reason. I tell myself that Pacific Ocean is so big that it's like exactly opposite to the Pacific Ocean, then why not make it like middle of the Pacific Ocean zero, except no one lives there, so it would be waste of time. A lot of people live. I'm not going to justify it, but this is randomly considered zero, and you measure longitude this way, and latitude, we are, well, let us say India is like starts at, I don't know, 7 north to, I actually forgot, but we can go to Google Earth. I don't know if they show latitude longitudes on Google Earth. This is an annoying exercise. Doesn't matter. I am somewhere here, and that is like 18-19 degrees from the equator. Equator is here. Now it is more visible. Equator is here. It goes through Indonesia and Democratic Republic of Congo, and so it should be here. And you measure the latitude from this way, and you measure longitude along this circles. So you understand this system. Now all you have to do is to take this grid. Just a second. Yes, my computer is very slow. You take this grid and you expand it, and now you're sitting inside the grid and looking at the stars, and it looks something like this. Now that is north, and now you have to, well, this is altitude azimuth mount in stellarium. Like you can see that I can move like this and like this, so I have to change the mount. I'll change, and now it is the good mount. Now it is called the equatorial mount. I think the background is too loud. I'm gonna go and just close my door. Just give me a second. I hope it is better, the audio. Otherwise, I'm going to yell a little bit. Anyway, so this I am now in a different mount, as you can see on Stellarium. So I can move this way and this way. What are these things? Okay, so what does latitude become in equatorial coordinate system? This is called the equatorial coordinate system, which is like the latitude longitudes, except the latitude is now declination and the longitude is now right ascension. And declination is very easy to understand. You just start at the equator. So this is the equator. So the Earth's equator, east to west. If when it expands and becomes bigger than Earth, this is what where we would see it. And well, we can't see the South Pole from India. It is like Earth is in the middle. Uh, let me show you why not. Let it become. I mean, it is very obvious why not. Earth is blocking it. And we can see the north. It's hard to navigate here. Okay, and we can see the north. And now you can see in this mount that Earth is not really important. It is that the outer space is so fixed and so unmoving that now Earth is like there slanted in the way randomly. But this is the references that we use, South and North Pole, and they are because of Earth's rotation. It is in a particular direction. That direction also, there is a thing about precession. I'll talk about it in another video, in the zodiac video. Um, so you have declination. Declination is easy. This is the equator, and declination is this angle, 0 to plus 90 and 0 to minus 90. Very simple. Latitude. So it goes from 0 to 90 n and 0 to 90 s, or plus 90 and minus 90. Very easy. Right ascension is also simple, except you need to remember where you don't even really need to remember, you just need to know where the Greenwich line is. But right now we are not using the Greenwich line because it might make sense politically or geographically on Earth, but we need a better reference in outer space, and there exists such a reference. um, in our orbit, we have a direction which is special to Earth. Now that would be, do you know that there are 2 days in each year where the entire Earth, all of the people on Earth, or I mean animals and everyone, we have 12 hours day and 12 hours night. And well, when we have summer, we have longer days here and shorter days in Australia, uh, or South Africa. It is the switched situation, right? In our winter they have summer, in our summer they have winter, but on equinoxes everyone has the same day. That's when things are meeting. Now these equinoxes are important, and what is the direction to a equinox? It is, well, on the day of equinox, if you take the sun and if you take the earth and you draw a vector through it, that is the direction to the equinox, and that direction is considered zero in this. So I'll show you where zero is. It doesn't really matter. It is kind of arbitrary because the tilt of Earth's axis is not like, it's not derived from gravity or whatever. It is just initial condition. Let me just move this. Oh, that is. Oh, well, this is how we see the Earth anyway, every day. You can see the moon moving and sun moving. Oh, yeah. Now, so this is the rotation of the sun around the Earth around a year that we are talking about. I don't know why I'm doing this, but this is what it looks like. We rotate with the Earth with our feet stuck to the ground. So we think that this sky is rotating, but this is what happens every day. And maybe I should zoom a little bit because Earth is not curved this way. Why am I doing this? I don't know. Please stop. Now, if you want to, oh, I wanted to find the zero. Now, how do I find it? Can I look at this and just guess where it would be? Let me think. Maybe when the sun is on north south, so this is the north south. Well, they're all north south. What the hell? They're all as good as each other. They go from north and south. Uh, so, well, we can just guess it. Rigel is here. You can see RA deck, and I'll explain the difference between J2000 and on date on the video of Zodiac, because that's when I'll talk about precision. You can see that the R angle or right ascension is 5 hours 14 minutes and the declination is -8. So it is below the equator. So the declination is -8 degrees, not 10. This would have been 10, 8. And it is 5 hours. And 5 hours, so it means that it is either 1, 2, 3, 4, 5. Either the 0 is here, or 1, 2, 3, 4, 5, and the 0 is here, because we don't know which way they are counting it. And if you say that the R is right ascension angle is counted along the east, then it should be somewhere here. So this should be closer to 0. Oh, this is farther actually. This is 10 hours. So 5 hours is here. Let us see. Oh, sad. So we have to wait until this happens. So we have to wait until the morning. That's what it means. Something like here. No, нет. Я хочу. So you have, yeah, this is like almost 0, 0. This should be even closer to 0. So this is the 0 line, and they haven't, yeah, it even says 0 hour here. And they haven't, like the stellarium hasn't made it a special line. But this is 0, and you count hours starting from here, and you go towards the east. And you count all the way to here, which is 24 hours. So it's a circular thing in all circular scales. You go 0 to 360 or 0 to 2 pi or 0 to 24 hours. And we have made it into 24 hours instead of 360 like the azimuth, because I don't know, you don't want to write 275. It's better to have two numbers, and then a decimal point. So it is like, for example, Jupiter right now is 21 hours 55 minutes and 3 seconds, 3.74 seconds. But it will change, like if I speed this up, see, it is changing. So you are saying, what is the use of this system if things are changing? Well, things are not changing for everyone. You look at Aldebaran, for example. No, Aldebaran. See, this guy's RA deck is not changing, it's constant. Jupiter is changing because Jupiter is a planetary body. It is moving around in space in real time. So it is changing. Actually, all of these stars are also moving, but I mean, they are not actually very slowly. They are moving with high speeds, but they are so far away, and the distances they are covering, they are so big that we don't have to update this for a while. Actually, in Stellarium, if I now I'm at Aldebaran, and if I go extremely fast, like extremely fast, you can see that it is changing. And how does Stellarium calculate that? It knows the proper motion of that star, and it knows where it is moving, and it is moving like, let me remove Earth. Let me also remove the names and stuff, unnecessary things. Actually, you can see that the entire, I'm making the zodiacal episode by accident. I don't want to do that. I'll make another video for it. Okay, now please do this. Tell me where Rigel would be. I told you that this is 0 in declination, and where was other 0? This is 1 hour and this is 12 hours. What? No, this is 24 hours. This should be 0 hours. Yes, this is 0 hours. So yes, this is 0 and this is 0. So this is 0, 0. Is it? Why does it say 12 hour for some reason? I don't get it. How can, see, it is 12 hours here and now it suddenly becomes 0 hours. Anyway, so this is 0, 0 on this grid. And you tell me what the Rigel's coordinates are, what are, I mean, you just have to guess. And then Deneb here, Sirius, you can sort of guess it, what it is. You have to, and this is declination and this is right ascension. You have to remember that. I will give you more practice problems so you it will get fixed in your head. Uh, but basically, yeah, those are the two coordinate systems. No one cares about altides. Just make sure you learn the equatorial coordinate system properly. I'll see you in the next video about zodiac and nakshatra and how does sun go through space and so on.